Okay, so this is question 16b from the physical mock. This is what I would call the ICE-MK method, or some people just say the ICE method. So the first thing we need to do is figure out some initial moles of the chemicals we've got. We've got 9.6 grams of our methanol, so we can use that to find the moles just by doing mass over MR, which will equal 0.3. And 12 grams of ethanoic acid. So again, we can find the moles by doing mass over MR, which will equal 0.2. So let's bang them under the relevant chemicals. So 0.3 of the methanol, 0.2 of the ethanoic acid. It doesn't tell us how much product we start with, but unless told otherwise, we would assume it's 0. It doesn't have to be 0. We could start with product, but we don't usually. So if you're not told any numbers, assume there's 0. So that's our initial moles, but we don't care about the initial, we care about the equilibrium, because Kc is the equilibrium constant, so it needs equilibrium concentrations. So the way I'd set it out, and setting this question out like this is really important, because it'll really help you keep track of your numbers. If you just try and do it all in like lines, you're going to get them mixed up. You're going to have loads and loads of numbers all over the place, and you're going to end up using the wrong ones. So setting it out like I'm doing now is my big tip for this. So the question will give you the initial moles, or a way of finding out the initial moles. It will also tell you one of your equilibrium moles. So we can see here it's told us the equilibrium moles of ethanoic acid, 0.03. We can use that to take into account the change of moles there, which would be minus 0.17, because that's the difference between 0.2 and 0.03. So just get a calculator. We can then use this change for the chemical we know about to figure out the change for all the other chemicals. Now, this is a 1-to-1 ratio, so this will also be minus 0.17. If this methanol had a big 2 in front of it, this would be minus 0.17 times 2. Yeah, so minus 0.34. And again, 1-to-1 and 1-to-1, it's a 1-to-1 to 1-to-1 ratio, so that will also be 0.17. Although as we are using up the reactants, look, they're minus, we're using them up, that means we must be making products, so plus on this side. So if one side is negative, the other side will always be plus, or vice versa. So taking those into account there, we're going to end up with 0.13 moles, 0.17 and 0.17. Now, usually what we then have to do is convert these equilibrium moles, because remember we're still dealing with moles, into an equilibrium concentration, because concentration is what Kc deals with. However, in this particular question we won't, because we have the same number of reactant terms as we do product terms. Why does that matter? Well, if I think about my Kc expression as this expression here, Blue Peter style one I made earlier, then I've got my concentration of my ester, but concentration is moles over volume. So moles of ester over the volume. I've got my conc of water, which is the moles of water over the volume. Conc of the acid, so moles of acid over the volume. Conc of the alcohol, which is moles of the alcohol over the volume. Now, if you do maths, you can probably see where I'm going with this. What are these volumes going to do? They're going to cancel, aren't they? So you're left with just the moles. So if it is that you have the same number of reactant terms as product terms, and here we've got 2 for 2, you do not have to convert your moles into conc. You can just stick your moles straight in. However, that is only true if you have the same number of reactant terms as products. If I didn't, I would have to convert those moles to conc. One other little thing as well, which was a bit of a common mistake, a lot of people didn't include the water in their Kc expression, and I can totally see why you're doing that. It's because if you have water and the rest of the chemicals are aqueous solutions, then you would not include the water because the concentration of the water would effectively remain constant. However, these other solutions are not aqueous solutions, they're pure liquids. Now, when you add a pure liquid to a pure liquid, they both dilute each other. Yeah, so the concentration of the water will not remain constant necessarily. So we do include the water because the other solutions are liquids and not aqueous. Okay, so all we then need to do is bang our numbers into this expression. So that's going to be products over reactants 0.17 times 0.17 over 0.13 times 0.03, and that will equal 7.41, or to 7.4, as the minimum number of significant figures the question went to was 2 and 2, so we should round our answer to 2 as well. If you said 7.14, you'd still get the mark, but really it should be 7.4. Okay, so ice, initial moles, change in moles, equilibrium moles. Usually you'd then have to convert the moles into the conc, but not in this case, and then whap it in the Kc expression.